In this video, we're going to learn about descriptive statistics. Descriptive statistics are just statistics that we use to describe or summarize data from a sample. This is in contrast to inferential statistics, which we use when we want to test hypotheses and make inferences about what is true in the population. But we're going to set inferential statistics aside for now and focus on descriptive statistics. Usually, descriptive statistics are the first type of statistics that we'll want to calculate in our data. They can be useful for a variety of reasons. First, they can tell us about who is in our sample. So if we collected demographic information about age, gender, race and ethnicity, where people live, we can use descriptive statistics to summarize those data and learn who is represented in our sample. Second, descriptive statistics can be used to learn about the other variables in our data set and how they're distributed. Finally, descriptive statistics can help us identify any outliers or errors in our data. And this is why it's a good thing to do to calculate descriptive statistics first before moving on to any inferential statistics that you're interested in calculating. In this video, I'm just going to go over some of the most commonly reported descriptive statistics. I'll start with measures of central tendency. You've likely heard of these before: the mean, median, and mode. It's important to note that we calculate descriptive statistics on each individual variable in our data set that we're interested in describing or summarizing. So, for example, if one of the variables that we collected was participant age, we can calculate the mean, median, and mode for age. The mean age is simply the average age in our data set. We add up all of the ages and divide by the total number of ages to get the mean. Usually the mean is the most commonly reported, but sometimes it's also useful to know the median and the mode, particularly when our data is skewed, which we'll talk about a couple slides from now, in which case the mean might not be very representative. The median tells us about the middlemost value. So returning to the age example, if we ordered all of the ages in our data set from the youngest participant to the oldest participant and counted toward the middlemost value would be the median. Sometimes if we have an even number of values, there are two numbers in the middle. In this case, we simply calculate the mean of those two values to get the median. And finally, the mode is simply the most common value in our data. For example, if we have more 21-year-olds than any other age, the mode for age would be 21 years old. We can have multiple modes, so if we have an equal number of 21 and 22-year-olds, both 21 and 22 could be the mode. After we've calculated measures of central tendency, we might also be interested in measures of variability. Measures of variability tell us how spread out our data is. One common measure of variability is the standard deviation. The standard deviation tells us, on average, how far away from the mean is any given value. So, for example, if our mean age is 21 and our standard deviation is 3, this means that, on average, any given data point is approximately 3 years from the mean of 20. If we have a small standard deviation, that means our data are tightly clustered around the mean. If we have a large standard deviation, that means our data are spread out far from the mean. So, for example, if we collected a sample of all undergraduate students, we would likely have a smaller standard deviation for age, whereas if we collected a community sample across the entire adult lifespan, we would likely have a larger standard deviation for age. There are many other measures of variability, but I just want to talk about one more that will be useful for you, and that is the minimum and maximum values of your variables. This is simply the smallest and the largest value. These can be useful for understanding the distribution of your data, but they can also be useful for identifying any outliers or errors. For example, if the variable is age and the maximum value is 212, this is likely an error that occurred during data entry or recoding that you'll want to correct. Next, let's talk about how our variables are distributed. To begin with, let's look at the normal distribution. In this figure, on the horizontal x-axis, you have the value of your variable. In this particular figure, it's shown in units of standard deviations, but you could show it in raw units as well. And on the vertical y-axis, you have the frequency or the probability of that data point. If your data are normally distributed, the most common data point will be the mean. About 2/3 of your data will fall within one standard deviation of the mean, and about 95% of your data will fall within 2 standard deviations of the mean. But not all data is normally distributed, and we can calculate descriptive statistics such as skew and kurtosis to learn more about the shape of our distribution. Let's talk about skew first. Skew tells us whether there are more extreme positive values that are larger than the mean, or more extreme negative values that are smaller than the mean. On the left here, you're seeing a negatively skewed or left skewed distribution. Here, the tail is pointing toward the left. And on the right, you're seeing a positive or right skewed distribution, where the tail of the distribution is pointing toward the right. If your data are perfectly normally distributed, your skew value will be 0. But if your data are negatively skewed, you'll have a negative skew statistic. And if your data are positively skewed, you'll have a positive skew statistic. We can also look at kurtosis. Kurtosis essentially tells us how pointy our distribution is. A normal distribution will have a kurtosis statistic of 0. But we might also have what's called a leptokurtic distribution that's pointier than a normal distribution, and then we'll have a positive kurtosis statistic. Or we might have a flatter distribution, which is called platykurtic, and then we will have a negative kurtosis value. Another descriptive statistic that we might be interested in is the internal consistency of any questionnaires or measures in our data set. Internal consistency tells us the correlation among different items that are measuring the same thing. So, for example, if we administered a measure-to-measure neuroticism, internal consistency will tell us how tightly the various neuroticism items hang together on that scale. There are various measures of internal consistency, such as Cronbach's alpha, omega, or simply the inner correlations among the items. The last type of descriptive statistic that I'm going to talk about in this video are correlations. Correlations tell us the relationships among our variables, and we may calculate a correlation matrix or a correlation table to tell us how our variables are related to one another. And that concludes this video of common descriptive statistics. I'll link some helpful resources for calculating these descriptive statistics in popular statistical software.